Your technical representative, Azapul Wadud, was kind enough to respond to my inquiries about your R12290U-52 phototube. It seemed to be a reasonable redesign of the Centron 1P39 phototube. And based on his answers to my question, the physical size and shape of your phototube is similar to what I need. But the distance between the anode and the cathode is way too small. And the $2,833 price tag is substantially higher than the $30 price tag for an antique Centron 1P39 phototube. Still, the 1P39 phototube geometry may have an undesirable effect on some of the readings taken during my research. Allow me to suggest a counterproposal. A couple of your engineers could easily reconfigure the R12290U-52 phototube with a 1/2 inch gap between the anode and the cathode. Forget any high voltage issues. Rename it and consider it a possible new item in your product line. Send me a prototype so I can test it for several weeks, and I will send you the results. Now, why on earth would you want to even consider this counterproposal? Well, there's a good chance that you will not want to consider it. There are always risks in new adventures. On the other hand, if this small effort on your part could lead to a bigger business opportunity a little further down the road, it could interest some of your executives enough to at least take a look at my counterproposal. My research has focused on measuring the loss of photon energy as light travels from one point to another. The loss of photon energy over distance is easily demonstrated with photodetectors of one kind or another, but the results of those experiments are systematically ignored by scientists who are heavily invested in the electromagnetic wave theory of light. Now, Wikipedia defines a photon as an elementary particle, the quantum of the electromagnetic field, including electromagnetic radiation such as light, and the force carrier for the electromagnetic force. The photon has a zero rest mass and always moves at the speed of light within a vacuum. And like all elementary particles, photons are currently best explained by quantum mechanics and exhibit wave-particle duality, exhibiting properties of both waves and particles. Now, while the previous definition of a photon sounds all scientific and mysterious, the embarrassing, unmentioned truth is that no scientist actually knows what a particle really is. What is it made of? How does it look? What is its normal routine? What is its physical relationship to energy, as described in Einstein's equation E equals mc squared? Well, I will make several comments about Wikipedia's definition of a photon. First of all, a photon is indeed an elementary particle. Light is entirely a particle phenomenon. There is no wave-particle duality. The electromagnetic wave notion has certainly been, and continues to be, useful. But the physical reality of an electromagnetic wave is bogus. The speed of light traveling through a vacuum will always measure as c, but it is incorrect to assume that photons always move at speed c. Every light source, even monochromatic light sources, emits a wide range of photons of various sizes and traveling at various speeds, some traveling at many times the normal speed of light. Detectors only absorb into their photosensitive materials photons that fall into a very narrow energy range. All other photons will be ignored and go undetected. The definition mentions the speed of light within a vacuum. The term vacuum used to mean a space devoid of everything. Now it generally means a space devoid of air. Considering all the stars in the heavens emitting photons for billions of years, space is literally filled with photons of light. We exist in an ocean of photon energy. Now, everything moving through this energy ocean is going to experience resistance, including new photons of light from our local sources. And unless those photons have some continuous self-propulsion system, they're going to lose energy and mass as they travel from one place to another, and they're going to slow down as a result. The slowdown shows up in this test, where relative photon energy decreases steadily over a distance of about 2.5 inches. The test was performed using a solar cell, where the distance between the photosensitive surface was separated from the electrical generation surface by only a few atoms. And this curve is ignored by the argument that the photons did not lose energy over distance, only the number of photons declined, resulting in lower energy readings. Well, that same argument does not work when the curve looks like this. This test was performed using the same lamp array with the Centron 1P39 phototube as the detector. It shows a rapid decline of the first batch of photons to a distance of 1.5 inches. Then, more energetic photons begin to show up as the distance increases. These photons were obviously present at the shorter distances, but too energetic to be detected. After they traveled a little further and lost some energy, they dropped into the energy range of the detector. New photons of increasing energy continued to appear out to a distance of 4 inches. After that, photon energy declined gently to the maximum distance of my equipment. My incandescent tests were performed using multiple RadioShack bipin 12-volt lamps housed in a 3x5 matrix. The Centron 1P39 phototube was used as the photodetector. The curve in question was produced when the matrix was powered at 3 volts DC. I used the matrix to project the most energetic photons at every part of the photosensitive cathode over the distance of the experiment. The study focuses on the early stages of photon travel from low-intensity incandescent light. There are several other very good reasons why the electromagnetic wave theory of light is bogus. If you are interested, I will explain them another time. The current unanswered question is this curve. The longer travel distance of electrons through a vacuum provides more sensitive readings. But the 1P39 semicircular cathode introduces an unknown. The electrons traveling from the cathode to the anode are all traveling the same distance, about 1/2 an inch. But the photons of light traveling from the source to the cathode are not all traveling the same distance, and they are not striking the cathode at the same angle. This may or may not have any effect on the curve, but it certainly raises some questions. Your R122-90U-52 phototube, modified with a 1/2 inch separation between the anode and cathode, could tell the story. With this modification, we would still have a uniform electron travel distance of 1/2 inch between the cathode and the anode. But the most energetic electrons detected would all have traveled in the same direction, unlike the 1P39 electrons all traveling from various locations on the semicircular cathode to the single rod centrally located, serving as the anode. The modification would ensure that we would have a uniform photon travel distance between the lamp matrix and the flat cathode. If the resultant curve demonstrates similar photon energy characteristics, then we have strong evidence that the electromagnetic wave theory of light is wrong, and we have a new basis upon which to consider the true nature of all the fundamental particles and forces. Now, if your modified phototube tells a similar story, then you have a new item to add to your product line. But since many previous phototube applications have been replaced with solid-state technology, current marketing possibilities would appear bleak. So, along with your new phototube, you need some new phototube applications. This is the equipment array that I use to perform photon energy tests. If this entire array of equipment could be professionally re-engineered to fit in a single structure, with the testing procedures controlled by a robotic microcomputer, you would have another product to sell along with the new phototube. The major external pieces of equipment could be reduced to circuit boards, all contained within a single structure. With a three-pronged electrical plug on one end and USB connections on the other, you would have a powerful educational tool that can help promote a needed change in the direction of some areas of scientific research. A new understanding of light, spread far and wide, will foster a new cadre of scientists with a better understanding of the fundamentals. I have considered offering this system development project to some university where any marketing proceeds could be used for scholastic grants. But if you have people skilled in electrical, mechanical, and robotic engineering and programming, perhaps you would prefer to guide this project through the design and manufacturing process yourself. Surely a simple phototube should not cost $2,833, but an entire testing system, including the new phototube designed for the educational market, might prove to be educationally, scientifically, and financially worthwhile. I mentioned some areas of scientific research that needed redirection. The electromagnetic wave theory of light is one of the two main theoretical foundations supporting the Big Bang theory. A red shift in the light spectrum from distant galaxies is interpreted as the Doppler effect applied to a light wave. A red shift implies that the universe is expanding because of an initial explosion, a Big Bang. But my experiments prove that light is not a wave, so the Doppler effect does not apply. The universe is not expanding. The Big Bang theory is bogus. The other foundational support is the cosmic microwave background noise. This background noise is interpreted as residue of the Big Bang explosion. Considering that scientists have no rational explanation as to what actually exploded and why it exploded, it is an irrational stretch to assume that microwave static is actual evidence of the explosion. I mentioned earlier that space is filled with photons of light. We exist in an ocean of photon energy. What those scientists heard was probably analogous to someone sitting on a bluff overlooking the Pacific Ocean, listening to the waves. In all likelihood, those scientists were just listening to light doing its normal, everyday thing. The Big Bang theory is a desperate attempt by frustrated scientists to convince the world that they can explain the origin of the entire universe, even though they cannot reasonably explain the nature of the simple, tiny, fundamental photon. In his book, A Brief History of Time, page 77, Stephen Hawking made reference to an experiment. He described it this way. In 1956, two American physicists, Cheng-Dao Lee and Chen-Ning Yang, suggested that the weak force does not in fact obey the symmetry P. In other words, the weak force would make the universe develop in a different way from the way in which the mirror image of the universe would develop. That same year, a colleague, Chen-Sheng Wu, proved their prediction correct, and she did this by lining up the nuclei of radioactive atoms in a magnetic field so that they were all spinning in the same direction, and showed that the electrons were given off more in one direction than another. Leon Lederman verified Wu's results with an experiment of his own. This was explained in his book, The God Particle. But neither the scientist nor the authors ventured a guess as to why the particles were not distributed symmetrically. Perhaps a unique arrangement of phototubes could provide some useful answers. Perhaps when you understand why the particles were not distributed symmetrically, you will see a myriad of other exciting possibilities. There is more to light than meets the eye. New frontiers of science await those who are willing to look. Send me that modified phototube and let me show you what is possible.